starting the recording. I would like to welcome you all to this first building block webinar of Prosperity for All, called Integration of Alternative Input Modalities into Educational Applications. This is the start of our Prosperity for All webinar series for developers, and within these sessions the developers can learn how to implement a Prosperity for All building block in their assistive technology solutions, and we will also showcase real Prosperity for All implementations. In this first webinar, we are proud to present the integration of AsTeRICS input device components into LIFEtool's educational games for people with special needs. The LIFEtool applications EURO and FlashWords have been enhanced with AsTeRICS components, so the end users can now interact with them through head movements or an additional acceleration sensor. The two applications will be provided as Prosperity for All editions for free in the unified listing. This webinar targets at developers and implementers who are interested in alternative input components for their own solutions and developments, and the webinar presenters will be Stefan Schürz, Alfred Doppler from LIFEtool, and Martin Deinhofer, part of AsTeRICS project team from University of Applied Science, Technikum, Wien. Here are some information about our presenters, and I would like to thank all of them. The first one is Stefan Schürz. He is a researcher at LIFEtool. He has been working in several national and international R&D projects concerning people with disabilities and elderly. He acquired great experience in usability studies in order to understand the real end user's reaction and has profound expertise in the user-centered design process. Furthermore, he is responsible for conducting usability tests and evaluations in the development process of human-machine interfaces. Alfred Doppler, he's a software developer also at LIFEtool for more than 18 years now, and during these times he has developed more than 25 programs for PCs, 9 apps for the iPad and 3 apps for the Android. His field of work is during the whole process of creating software, from creating user stories and storyboards to write code, from adapting graphics, from the needs to cut audio files and music, from testing and packaging the software to bringing it into the actual store. And last but not least, Martin Deinhofer. He is working as a researcher and lecturer at the Institute of Embedded Systems in the field of assistive technologies since September 2013. And he was and is still involved in the AsTeRICS Academy project and Prosperity for All, and he is one of the main contributors to the AsTeRICS framework. This is the agenda that we will follow today. First of all, we have our welcome, and then we have a short introduction into the Prosperity for All developer space that will be realized from Ignacio Peinado from Raising the Floor. We will continue with the introduction of LIFEtool and developments from Stefan Schürz. There will be the presentation, and also questions and answers will follow its presentation. Then there will be the AsTeRICS demo, model creation and packaging from Martin Deinhofer, and the integration of Prosperity for All components from our Alfred Doppler. And in the end, we will have our sum up. So, I think it is time to start. I will pass the floor to Ignacio Peinado from Raising the Floor to tell you some things about Prosperity for All and especially the developers space.
Well, good afternoon to all, or good morning, or good evening. Can you hear me okay?
Yes, Ignacio.
Okay, thank you. Well, thank you, Eleni, for the introduction. As Eleni has said, my name is Ignacio Peinado. I work at Raising the Floor International, and well, in Raising the Floor, if you don't know it, we are developing a very big concept. That's the Global Public Inclusive Infrastructure, or GPII. and well, we're building it through different projects, and one of them is Prosperity for All. So as far as Prosperity for All, we are developing a website that's called the developer space. And what we aim is that the developer space to be a one-stop place where any developer or end user can find any resource, and when I mean resource, I mean information, tutorials, learning material. Also, one of the most important parts are the building blocks. I mean, those are like code snippets, libraries, or other resources, so they can build accessible solutions or improve the accessibility of their own solutions in an easy way. We also aim to facilitate that developers can contact other developers or testers, and that also to provide support for developers of accessible solutions throughout all the value chains. So since they start having the idea until taking that solutions they have developed to market. So it's now a work in progress. The project is entering its third year, and well, we're working on having a first stable version of the developer space by the end of this year, I mean this month, with content by the end of January, but I would like to make a brief presentation of what we have so far. This is staging site, so if you want, you are invited to sign up through the Prosperity for All page to get informed, so you know when we release the first beta version of the developer space. And as I told you, well, as you can see here, well, we offer parts and tools where you can find all the libraries and components, that among them some of the ones that you will learn from today. As you can see, you can search through facets. So here you can see some of the resources we're using. And well, you're invited to check the website. And well, as you know, this is a work in progress. Any feedback will be more than welcome. As I told you, this is the staging site, so better not sign up here. You're invited to log in when the production site is up. But right now, it's possible that when we move to the production site, some of the data may be lost. So you're invited to visit the site and log in and sign up just to stay informed, and we will get back to you whenever we have something, whenever we have the production site up. And of course, any feedback you have about the site, any expectations you might have, you can contact us. We really like to hear from people who will use the site, so we're open for any suggestions. And that's all for my presentation of the developer space. So if you have any questions, or Eleni, or you want to move on with the building blocks, I know the time is tight.
First of all, Ignacio has wrote in the chat area the links for the Prosperity for All website, how to sign up, and the developer space. If you don't have any questions, we can go on with the presentation. Okay, Ignacio, please go on. Move on.
Thank you very much. Now it's time for the next. I think it's for Stefan. So thank you for your attention.
Thank you, Ignacio. Yes, indeed. we are going to Stefan. So Stefan, I will make you presenter so you can share your screen now.
Thanks. Okay, so welcome everybody. My name is Stefan Schürz. I will now present you the part of the introduction of the LIFEtool and the developments we have here ongoing. And so we'll start by telling you that LIFEtool is a non-profit organization, and we are founded by Diakony and also the Austrian Institute of Technology. And what we do is that we offer counseling and training services for people with special needs on appropriate augmentative and alternative communication products. And moreover, we develop educational and accessible software programs and apps, as well as also other computer input devices, like the awarded Integra Mouse Plus, which is a mouse-operated mouse for people who are not able to use their hands in order to control the computer. And apart from that, we're also active in different national and international R&D projects for people with special needs and also elderly. And what we want is to stimulate the advancement of assistive technology, and this also in the focus of the benefits for people with special needs, including also seniors. So what we offer is a broad research network to potential funders and also to cooperation partners, together with universities and private research institutions. And we have excellent access through our counseling network and through our owner, the Diakony, to the different target groups like educational institutions, hospitals or nursing facilities, and rehabilitation centers. So our clients are always actively involved in the innovation process. So their knowledge is collected within the range of more than 1,200 consultations per year. And so we are able to learn in depth about their needs and the requests of our customers. And so we earn valuable solution-oriented skills. And the integration of our customers in the solution process leads to the high acceptance and ensures that our new products can be developed efficiently and effectively. And what we do is that we have an interdisciplinary team which works our main way since our foundation day, and so we've learned to use the strengths of each discipline for the solutions for people with disabilities and seniors. And we have developed a variety of educational software and apps, and we have experts from the fields of technology and education. And so we have software requirements for different areas are developed together with internal users. And so we have apps for early intervention games, acquisition of culture techniques, language promotion, and also supporting of learning disorders, for example. And we attach especially importance to intuitive operation and also to a simple and logical UI for people with special needs. So the people and their needs and their capabilities are always remaining in the central point of the entire development process. So as a result, we offer a broad range of different input modalities for the different disabilities people have. And with the help of the Prosperity for All project right now, we are able to enhance our lineup of input modalities for our apps. So I'll come to this later. So here's just a quick overview of the different applications we already have. They are now can be bought on USB or can be downloaded for PC. But we also have so our apps in the App Store, in the iOS App Store, and also some in the Google Store. So the application we are talking right now is our FlashWords application, and so we have made in the project now a FlashWords Prosperity for All edition, and this application targets persons who can hardly speak or have only insufficient speech abilities. So this condition is often found in children with Down syndrome. So because they often have special problems with the speech development, like the hearing or speech motor function or comprehension. And so FlashWords is based on a concept described in the series of small tabs, which is called early reading. And early reading is an international acknowledged method which was developed by the Special Education Center at the Macquarie University in Sydney. And basically the concept is about to confront children with whole worlds at a very early age. And this has a very holistic approach to their reading. So the words have a visualization, and this can compensate auditory problems, which means the hearing and the processing of things heard. So we saw that if language is made visible through signs or written words, that it can support the auditory memory. So yeah, a great number of these problems are also well known in children with disabilities or delayed development. So what we did here now was that we included the component of the Prosperity for All developer space, which is called the camera input model. And this helps us to reach more people or more kids with motor disabilities. And so this is like a basic head tracker functionality, which is provided by the webcam of the laptop or of the desktop. So right now with this input model, the head movements can be used for input of the game. So I will now jump into the game to give you a quick overview. So right now I'm operating the game with my head movements. Okay, and then the next application I want to present you is our application called EURO, and this is an app which helps our users first to get to know about money and the knowledge of individual coins and banknotes and the value of money. So children and young people should get the feeling for how much daily life costs, and such as food and drug products and also other everyday objects. And what we did here was also that we included a model of the Prosperity for All developer space, which is called the acceleration sensor input model. And both of these models were provided by the University of Applied Sciences in Technikum Vienna. And I quickly can show you now also the second application. So this is now operated by the acceleration sensor, and so the whole UI gets scanned automatically, and when I move the sensor, the click is going to be released. So it asked me now, this application is in German, but it asked me now if this is the same amount of money. I say no. And yeah, this is basically some exercises we have here. So, yeah, and this was now the end of my presentation. And yeah, for more details, my colleague Alfred will tell you then about the implementation stuff in detail. And yeah, I'll be happy to answer questions.
Are there any questions for Stefan? Okay. We should move on to Martin. So Martin, I give you the floor. I will make you a presenter. Martin.
Okay, thank you. Can you hear me?
Yes, loud and clear.
Okay, that's great. And let's start. Okay, thank you, Eleni. As Eleni already said, my name is Martin Deinhofer, and I work at the US Technikum Wien in Austria. I will do the AsTeRICS introduction part, and yeah, I will show you some short demos of AsTeRICS. I will also demonstrate how to create such a solution like the AsTeRICS camera mouse, and finally we'll also demonstrate how you can use the packaging environment to create some custom deployment packages. At the beginning, just some few words about the US Technikum Wien. We have about 12 bachelor and 17 master programs and about 4,300 graduates and 3,000 students. And the R&D main areas are in the field of embedded systems and also including assistive technologies, e-health, tissue engineering, and renewable energy. So what is AsTeRICS? AsTeRICS is a flexible...
Martin, I am sorry to interrupt. Yes? We cannot see your screen.
Ah, okay.
Yes,
better now?
Much better. Thank you very much.
Thank you. What is AsTeRICS? AsTeRICS is a flexible assistive technology prototyping tool, and it is able to deal with special requirements in the field of assistive technology, which means it can deal with unique sets of capabilities of single users. And also with changing capabilities over time. For example, if a user has a degenerative disease or even a progress due to rehabilitation, for example, or has changing capabilities due to fatigue, for example. Or in some cases, it could also happen that the user has changing needs and wishes over time. So the goal of AsTeRICS is to be a rapid prototyping tool so that people can very easily and rapidly create assistive technology solutions for such uses. The AsTeRICS project was originally funded by the EU STRAP program from the FP7, and it was developed between 2010 and 2013. And there were two follow-up projects. One was called AsTeRICS Academy, and the second one is the Prosperity Fall. What are the basic principles of AsTeRICS? There are two major components. One is called AsTeRICS Configuration Suite, or also called ACS. And the second one is called AsTeRICS Runtime Environment, the ARE. And with the configuration suite, you can create assistive solutions with a graphical editor, where you simply put in some graphical elements. We call them plugins or components, and you can simply interconnect signal paths of that plugins to other ones. And for example, in this case, you have this plugin has an output port and sends data out of this port, and you can connect this port to another plugin where the data is transmitted to that input port. Furthermore, the plugins have properties which you can use to adjust the behavior of the plugin, and finally there are also some event mechanisms, so you also can trigger or listen to events. This all can be defined in the configuration suite, and then you can execute that program. Let's say program, we also call it model, and you can execute that in the AsTeRICS runtime environment. And that is the execution environment that interfaces the sensors and actuator hardware and processes the data. There are many plugins available for AsTeRICS, and among some of them are, for example, this webcam-based face tracking you have already seen in the integration of LIFEtool, or you can also use eye tracking. Then you can use external switches. You can create scanning-based user interfaces. You can use keystroke and mouse emulation, and also do capturing and remapping of keyboard and mouse input. Then you can interface smart home and environmental control hardware, or interface to microcontrollers, create solutions for accessible gaming, and finally also use bioelectric signals to, for example, to use EMG signals like from a muscle contraction to create a mouse click, for example. Here are some more technical facts about AsTeRICS. The ACS is written in C# and is only available for Windows. This uses the ASAPI interface that connects it to the runtime environment. Then within the Prosperity Fall project, sorry, just short interruption. Within the Prosperity Fall project, there's this web-based version of the ACS, and this is based on HTML and JavaScript, and it uses a RESTful API. And finally, there's the AsTeRICS runtime environment, which is implemented in Java and OSGI, and provides the plugins that I mentioned before. And the runtime environment is available for all platforms, and there are only some plugins that use Java native interface and native code, for example, native code of OpenCV, and those are just available on Windows. And here you can see a simplified version of the system architecture, and as you can see, there's the runtime environment with several plugins as OSGI bundles, and then you have this new interface, the RESTful API, and also a WebSocket. And so software like the one from LIFEtool can remote control the runtime environment through this API. And also the new web-based version of the ACS uses the new API and can upload and download a model file. Now let's go to the AsTeRICS demos. The demo release that was also sent out in the invitation link contains demos about camera input modalities, about biosignal acquisition, about smart home integration, microcontroller use, heat emulation, and many others. And there's also a web page that explains the demos and also shows some examples for the REST API integration. So the web page will look like this. We have a description about a demo, and then you can deploy and start that demo as soon as you have a running executable of the demo installer. So what are the requirements? You need the demo installer, and you also need a Java runtime environment. And for some demos you would also need additional hardware or software. But for now, let's start with the demos. Okay, as I said at the beginning, you will need the demo package running. I already installed it on my computer, and so I just start this executable of the demo. It's called AsTeRICS Prosperity for All Building Block Demos. So now I can, in this demo, I will demonstrate the camera mouse. And as you can see, there's also, you can also select the camera to use and the speed of the mouse emulation. I will now use it with the default settings and click on Apply and Start Model. And it should then automatically deploy the camera mouse demo. And as you can see, when I move my head, the mouse also moves accordingly. And for example, when I click onto that element, you can see my head moving. And in this window, the video frame that is tracked by the webcam is visualized, and also the tracked nose and chin movement is also visualized with the red circle. And you might wonder how clicking works in this application. It works with the so-called dwelling, which means if you rest at a certain location for a certain amount of time, then clicking is performed. For example, if I go to the Explorer folder and stay there, the folder is opened. Okay, if you press F7, then you can stop the demo model again. Let's go to another demo. I would like to demonstrate one about smart home integration. And this one will show a simply scanning-based user interface that should allow people with very few modalities to also control their TV and Hi-Fi or their lights, for example. So when I start the demo, the user interface will start, and as you can see, the lower part alternately starts blinking. This is the scanning mode of the user interface, and if you press the space button, then the scanning selects the row, and if you press the space button again, the scanning also selects the column. And now I got into the sub menu for the Hi-Fi, and so if I once again select one element of the user interface, for example volume up, then you can see in this debug output that it would send this command to the infrared device that was attached to my computer. But you can, of course, you can also operate the user interface by normal mouse operations. And for example, could also integrate KNX technology, which is smart home bus system for environments. And in this example, if you click on the living room on the on switch, then you can see that also the KNX will get a command string. Okay, then now let's go on to the camera mouse model creation. In this example, we will now see how it works, how you can create such a solution on your own with the ACS. If you want to do it on your own, you need the full AsTeRICS version 2.8 installer for Windows, and also you will need a webcam. There's also a complete tutorial that you can find here. I will simply demonstrate it with the real software so that I can also show it to you and execute it. Let's stop the demo ARE first. And now I start the ARE of the AsTeRICS framework. I will also start the ACS of the AsTeRICS framework. And in this drawing canvas, you can create your assistive solutions. If you click to the Components tab, for example, then you could either browse through plugin menus, for example, go to Computer Vision and select the Cross Face Tracker LK plugin, or you could also enter a search string, for example, mouse, and add the mouse also to the canvas. Then, in our case, we would like to transfer the head movements to mouse movements. So what do we have to do? We simply take the tracked nose coordinates and use them as mouse coordinates. So I connect the nose X output port of the X Face Tracker LK plugin and connect it to the mouse X input port of the mouse plugin. And I do the same for the Y coordinate. And that's almost all. There's just one thing I also have to adjust in the properties of the mouse plugin, which is I have to deselect the absolute position properties, because the webcam based tracking does a relative tracking. It doesn't know about absolute coordinates, and so the mouse plugin knows that it has to sum up the movement changes. So how can you test this model now? Simply go to the System tab, connect to the ERE, upload that model, and start it. So, hello again. And with this model we just created, you just have this very basic tracking, but there's no clicking emulation and stuff. And as you maybe also can see, the quality of the tracking is not perfect, and so normally you would add some filtering to reduce the jitter of the movements. Okay, that's it. Now let's go to the AsTeRICS packaging environment. What is the packaging environment? Or also called APE. With APE you can manage your AsTeRICS AT solution as a dedicated software project, which means that you can use a project structure template, you can use a set of tools and build infrastructure, you can use that to create a downstripped version of the ERE. So this means in this downstripped version you only have the plugins and configuration files and stuff that are needed for the execution of your model. We don't need the full framework and you will have to install the full framework for the execution of your solution. So this way you can also customize the ERE. You could, for example, replace images and config files and create and host your own AT solution as a software project. Furthermore, it's possible to create a native installer and a native launcher for your solution. For example, for Windows you can create a .msi or .exe installer, and for Linux, including Raspberry Pi, a Debian installer, and for Mac OS X, a DMG installer. You could also select to embed a Java runtime if you don't want to have, if you don't want to let the user have to install the Java runtime environment. And it also helps in license management, which means that it provides a set of involved license files, and you get an overview of the involved licenses, and this way you can decide on your own about the license implications when using that solution. And it's also possible to choose between two licenses. One is the GPL version 3 with ClassPass exception, or the second one is the MIT license. Let's have a look at the intended workflow of the AsTeRICS packaging environment. The basic idea is that you first create or modify a model file and save that model file or model files to your APE project location, and then build your project. This then creates a custom ERE. You can then test the ERE and modify the models again. And as soon as you've found a working solution, you can deploy that solution and create a native installer and native launcher. That's the basic idea behind it. So where can you find APE? It's included in the full AsTeRICS framework installer and can be found in the subfolder APE. and it's also included in a platform-independent.zip file. And on the right side, you can see the basic structure of the ape directory, including the ape command line tool and also the project template directory and a default project directory. Here's an example of how to use the ape command line tool. There are two modalities. One possibility to use ape is the command line tool, and the second one is to use the project structure and build tools. With the command line tool, for example, you would use it like this. You call ape copy and then provide the path to a model file that you would like to use for your assistive solution. And then ape copy creates the downstripped ERE version for you. The second option is to use the build infrastructure and the project template. And if you want to use that, you would copy or save your model files to the project directory into a subfolder, and then go into the project directory and call end ape copy. Then you also have a properties file that lets you configure your project. For example, you could define that your base ERE is, for example, of the full AsTeRICS framework installer, or it could also be from the current master tree of the GitHub repository. Then you could also define several model files that you would like to add to the project. And you could define a custom build directory. And what's very interesting also is that you can define the type of installer you want to create. And furthermore, there are many properties that let you configure information for the installer creation. For example, you can define the name of the installer to create, the name of a software package, and also the version of it, and also add some additional information about it. So let's now test this approach, and I would like to show you how to create this camera mouse I just showed you before, the very simple version one, how you packaged it, how you could package that version, and how you could execute this customized ERE. I still have opened the camera mouse solution from before. So at first I will save that model.
Martin?
Yes?
Sorry to interrupt again, but before going on, we have a question from Jim Tobias, who might drop off in a while, so I don't see him,
just let me...
maybe he has dropped off already. Unfortunately, we didn't. Okay, maybe go on and you can answer the question privately afterwards. Yeah, he has dropped off.
Okay.
Okay, go on. Go on, thanks.
So I will now save the model file of AsTeRICS to the location to the default project location of ape. So this is the default installation directory of AsTeRICS. Then I go to the subfolder ape, and here in the dev project, here is the default project directory that you can use for your first project. So I just go into subfolder custom bin ERE and models and save my model file there, like cam, mouse, webinar. Okay. What's next? What does my slide say? Okay, then I just saved my model file to the folder. Now I will change to the default project directory, added the app.properties to change the application name, and then we will call add app copy to create a custom ERI. Sorry. So let's open app.properties. And in my case, I will change the application name to mouse webinar. Then I will open a command window. And pull and app copy. And here you can see that it found a model file on the location custom win ERI models cam mouse webinar. This is the model file that was used for the custom ERI, and at the end of the informative output you will find the path of the custom ERI, which is in the subfolder build merged. Oh, sorry. So this is my custom version of the ERI, and you can now start it. And as you can see, this is the model file that we just created, and yeah, it starts automatically. And to be sure that that's the model file we just created, you can see that there's no clicking functionality. Okay. So let's stop it again. And now you could also create a deployment file with and deploy. Let's see what happens. It does the app copy command from before again, and afterwards it calls the installer creation, which means on the Windows platform this will automatically create an installer file for .msi and .exe. And if you want to create an installer for Linux or Mac OS X, you have to run this command on your target platform first. So this may take some more seconds. Okay. A few more seconds. So finished now. And as you can see, there and those paths you can find the created installer files. If you now go to that location, it was in the build, deploy, bundles, you find an exe and an MSE installer, which has the size of 48 megabytes. Let's click to install. And the .exe installer should also automatically start the application, as you can see. So the install then started automatically. Okay. That's all about the ape demo. Now let's go back to the presentation. Yeah, finally I would like to tell you something about the Prosperity for All building blocks repository, which is the repository containing the AsTeRICS demos that I just showed you. And the repository is organized in subfolders, which are ape-based projects, and you can use those building blocks as standalone building block, or you can also use it in this demo bundle. And yeah, you could use those template projects for yourself. You could fork them, you could reuse them, and maybe you will also find useful to see the screencast that is at the README of the P4 building blocks repository. And finally, some links again collected for you. And so yeah, I would say that's all of my part, and I would like now to give over to my colleague Alfred. If there are no questions anymore, sorry.
Thank you very much, Martin. That was great. If you have any questions, Martin is now available to answer them.
Was anybody able to try this on his own? Sorry?
Yes, hello, Alan.
Hello, Alan?
Martin?
Yes?
I thought that someone wanted to make a question. No?
Has anybody of you tried to execute the demos on his own or her own?
I think Alan is trying to say something.
Mm-hmm.
But
okay,
we cannot hear him. Alan, would you like to try to speak? Your mic is on, but I cannot hear anything. He's typing on the chat, Martin.
Okay, I will watch out the chat.
In any case, Martin, it would be better if you answered both typing and orally so everyone else can hear.
Okay. Alan wrote that he was curious about the web-based construction set and directions for that, and because he's primarily developing on a Mac. And so Alan, the web-based ACS is, yeah, I wrote it in a more or less alpha version, but this is developed by our partners from Linz, KII, and they recently told me that that it's available for first tests, and I was also thinking about already integrating it into the demo page. So simply go to the repository of the web ACS. I have contained the link in my slides, and try it out on your own. I think most of the functionality is already implemented and it's not far away from being really usable, I would say. Okay. Does anybody else have a question?
Okay, Bokar, would you like to open your mic?
Hello.
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 Can you hear me?
Please go on with the question.
Okay, I did type it. I've been playing around with the AsTeRICS and the models. Some models load, but some don't. What would be the obvious thing to look at? Why?
But what did you try actually? What were your steps? Or?
Randomly, you know, the camera actually did work, for example. The Gmail, I was not successful. Yeah, that's one example. I was not able. When I tried to load it, it just, nothing happened, and I'm trying to see what, I did not get any obvious errors.
What, could you say it once again? Which model did not work?
The Gmail.
The Gmail. Okay, but there's no Gmail demo included in the demo installer.
I'm sorry, actually that's the AsTeRICS in general. Yeah, I think your AsTeRICS demo, actually, when I double click on it, nothing load. And I also did try the AsTeRICS in general.
Yeah, the full framework, okay.
Yeah, yeah, so what would cause that?
What do you mean?
I mean, why I'm not able to load the AsTeRICS Pro demo, even though I was able to load the AsTeRICS, the R.
Yeah, the ARE.
Yeah, so is it my environment, or is it something I'm missing, or I guess the Java runtime environment. I mean, I thought it was preloaded on the R, right?
Yeah, it can happen. It can be for some models, for some assistive solutions, that you also need external software. That has to be installed before.
Yeah.
So it depends on your solution also, of course.
Yeah. I mean, just out of curiosity, if you encounter some of those issues, and what the quick way to fix those.
Okay. Yeah, as you know, it's difficult to give an appropriate answer with not having a lot of detailed information about the problem. So maybe, but maybe I can help you afterwards via email. So
yeah. Okay.
You can send me your problem, and I would help you. Okay.
Okay. Thanks.
Is anybody else with a question?
Well, the emails of the presenters will be made available to everybody. So if you have any specific questions that you would like to ask them, you could also do it after the webinar in person. You can send them an email with more specific things that you are concerned about, and they will be able to answer. Martin, I was wondering if, even a bit late, you could check and answer Jinto Abaya's question.
Okay.
This is about He says, I will ask a question here. How do you visualize this integrated into GPII? For example, let's say the GPII wants to do install on demand of an AsTeRICS solution onto a random PC. How will the presence, absence of, let's say, an appropriate camera be recognized and handled?
Mm-hmm. Yeah, thank you, Jim, Tobias. It sounds like a very interesting question. And but in fact, yeah, it's also not so easy to answer, I would say. I think the first part is that, for example, there could be stored some AsTeRICS model files in a preferences server of the GPI, and the model file could be deployed automatically to the runtime environment on a computer. And the part of how to detect the camera in advance, I think this would have to be outside of the AsTeRICS environment, because within GPI you have to detect your hardware environment in advance anyway, because it has to find out what are the preferences of a user and what is the environment of the user, and the GPI should then find an appropriate solution for that. Okay, I hope I could answer that question now.
Okay, Martin. So thank you very much. I think it's time to give the floor to Alfred. Thank you very much, Martin. It was very interesting.
Okay. Thank you.
So, hello, this is Alfred Doppler. Could I please have the, thank you. So, okay. So, what I'm now talking about is the integration of the Prosperity for All components into our software. I'm a developer for quite a long time now, and the University of Applied Science, Technikum Wien, delivered us 4 models we should try to integrate into our programs. We had 2 different programs in mind where we could use these things, and we first wanted to check out how these models behave, how they could work, and how we could integrate them. First one was the click with the head movement. This means you are there is scanning in our program, and there is a frame that is moving, and you move your head, and with the head movement you click. That's basically it. And the same thing would be a model where you don't use your head for clicking, but you would use an acceleration sensor to make this click. This means you may raise your arm or your foot or something like that. The third model was moving the mouse with the head movements. This means you could really control where your mouse will be, and you could really control the exact point where you want to have a click. And you will click with dwelling. This means you would rest on some area for a time, and then at this position, the click will happen. And the fourth model was move the mouse with the head again, but clicking with an external button. So the first thing we were checking was the click with the head movement, so that you really can keep up with what I'm talking about. I briefly explain scanning now. Scanning means that you have some frame. In this case, you can see here a blue frame around one of our lessons, one of our exercises, and here this blue frame has moved from the first exercise to the second exercise. And when you make a click, This means when you tell the computer, now is the time that I want to select this thing, then the position of the blue frame will decide which exercise will be started. In our case, we are using space, enter, or left mouse button to select this object. So nearly all degrees of freedoms are there for the user to control the system. For the first model, where we click with the head movement, we made this with one button scanning. This means you need only one thing to press, no matter how, and we take this input and start the exercise where the scanning frame is. We had two different sides of controlling this thing. One thing was, if you move your head, if you make it very sensitive, then small head movements would already click. This is not good, because in this way the user would make clicks without even wanting to do them. The other thing is, if you don't make it sensitive, you need big movements to really make the click at the time when you want it. So these are the big extreme sides, and when you go into the middle, on the one side you will make clicks when you don't want them, and on the other side it's like you don't get the click even though you moved your head. So if you have control over your head, you can use an external mounted button. You would put the button by your left ear, for instance, and then you just press this button with your left ear, and then you click whenever you want. Or you can even use the Integral Mouse Plus. This would be a real mouse where you can even left and right click. So there are different solutions for different other solutions for people who can use and control their head good. So the next thing would be we check the model with the acceleration sensor. The acceleration sensor means basically that you have a sensor mounted. For instance, here you have a picture of the acceleration sensor mounted on my arm, and you just raise your arm or lower it. The target audience would be people who are able to lift their arm, but who are not able to hit the button. This means they have some kind of controlled way of raising their arm, but not in a direction way, just in a spontaneous way. And so in this way, what you can see on this slide is, on the left side, we have a model where you can see all the data that will get delivered from the sensor. Here you have the oscilloscope, where you can see how the data is delivered, and here you have a full pitch of the arm it has just been raised. Because of that, here this exercise would be started, because we now just got a click. We had some things with this sensor that did not make us happy. One thing was the sensor uses a USB cable. If you have, you can see it here on the arm, if you have a person who is not really able to control their hands good enough to hit the button, then a cable may not be the best idea. This speaks a little bit for trouble. The other thing is the sensor costs around 79 euros. That's not exactly cheap. And one thing that was really also annoying from an end user point of view is you don't have plug and play. You must install the special driver. And for Windows, it took me about 2 reboots and to go into the BIOS to really install this driver. So that's not a thing you normally want to give into the hands of our end user customers. So we were thinking about, okay, what about other state-of-the-art wireless solutions? I mean, now these fitness armbands and activity trackers are all over in the news. So why don't we just use one of these? And they may cost something like 20 euros or so. And so we checked and looked around. And one of the big disappointments and surprising things for us was that there are normally no APIs for these things. And if they have APIs, they are only for iOS and Android. So in this way, the normal standard activity trackers are not really viable. I contacted 2 of these device makers who said they have an API, and both said, no, we don't get any raw data access because we don't want to know how many steps people walked. We need the raw data to know that somebody raised their hand. And so in this way, these 2 activity trackers were no thing to keep on going, but there was the angel sensor. The angel sensor is was a very successful Indiegogo campaign. It was more than 300% overfinanced, and it was a tool, a gadget from developers for developers. So this was really the things they said they will deliver and that will come there, especially the acceleration was very interesting. So in November 2015, I contacted the developers and I get in touch because I wanted to ask how is the raw data access and all this kind of stuff. And one thing that kept us from taking this thing was the device could not be ordered. This was a thing where because there was no way to get hands on this device. Yeah. The other thing that was also troubling us was the data could only be accessed through the cloud. This means when you want to know if somebody raised their hand, the data from the armband had to go through your Wi-Fi connection onto the internet to a cloud server. From the cloud server there should be some kind of web app that gets the data for you and then sends it to your local AsTeRICS on your PC to have a reaction. I would say at least 300 milliseconds latency, probably half a second. And when I checked about 4 weeks ago, I realized this project now, the website, is even closed now. So this means, because I then started to read the forum, the people there are really unhappy now because there are more than 2,000 people who backed up this project and nobody did get any device. So in hindsight, you could say we could be kind of happy that we did not get this device, because otherwise we would have totally developed in vain, because just now nobody can get this thing anymore. So this was our excursion into the armbands. It was not very successful, but another armband we got from a different project is the mirror armband. This device can be ordered, so that's a thing that's really, really important. When you try to develop something with a special input device, you need the device. From a developer's perspective, there are so many things that will surprise you when you have this thing in your hands. So it's really, really important to get this thing on your computer, on your PC, and try it out in different test systems. What this mirror armband does very good is the standard gestures work very good. This thing works with the current in your muscles. This thing has 6 small sensors here. Yeah, 6. I think it should be 6. Oh, sorry, 8. It's 8 different sensors. These are all this kind of plates, and they get the current in your muscle. This means when you make a fist, or if you wipe from left to right, then the current in your muscle will be different, and this armband realizes this and can tell you, oh, this was a fist, this was a wipe, yeah. And the raw data is directly sent into the PC. This means there is no latency, it's just directly there. They have a very nice browser app. This looks like this. So you can open the browser, and this armband will directly deliver from these 8 sensors the direct data they get. Yeah, and also here on the bottom right, you can see what gesture this app just now recognizes. And here, this cube shows you how this armband is oriented in the room. This means in this way you have a gyroscope, and you also get velocity and all this other kind of stuff. So it's really nice, and all the data is there. So the thing was, why did we not keep on going with this thing? Was one thing is it costs $200. That's not exactly cheap, at least it's not for everybody. The other thing is, because this thing checks for the small currents in your muscle, it means every single time when you put it on your arm, you have to calibrate it, because it is nearly impossible to put on this armband in the same way like last time. If you put it only 3-4 millimeters aside from last time, the current in your muscles will be different, and the armband will not be able to recognize that you are just making a fist. So every time when you put it on, you have to calibrate it. This is okay for a presentation, but for a daily use, or imagine you have a mouse, and every time when you want to use your mouse, you must make 5 clicks until you're able to use it. Yeah, you would just stop using it. And the third thing was, this mirror armband comes with a driver that already makes left clicks for fist. This means when you make a little bit of configuration work, then you can use this armband for making a left click with a fist, and so there's nothing really to develop. This driver is already there, it works good. So that's the reason we did not go on any further, because we wanted to develop something. So this brings us to the last two models, and this is the model with the head movement and click with dwelling, and the model with head movement and click with an external button. If you look from it from a higher perspective, it's basically the same model regarding the head movement, and just a different form of selecting the object under the mouse. So AsTeRICS fully covers all external buttons. I don't think there's any button that AsTeRICS cannot use. So if we can dwell, this means if our application can dwell and make a click with dwelling, then the external buttons are already covered. For this now, I briefly explain dwelling, because I'm not sure if everybody knows what dwelling means. It means that if the mouse stays for a while on a clickable object, a circle, part of a circle, starts to appear, and it is slowly filling up. And when this circle is full, then there will be a click on that object. So in this way you can decide how fast this circle is filling up. For people who are faster, it can fill up faster. For others, it will fill up slower. But that's dwelling. This means you only have to control the mouse. You don't have to make any click by hand. This means when you're not able to click, but you are able to look, like the Toby with the eye control does it, then you even can make clicks just by looking on some object. So you already have seen this picture. This is what all speaks for this head mouse. This camera checks for the nose and chin, and wherever you're looking, the mouse is following. You don't need any calibration. We tested it out with glasses and even with very bright rooms and very dark rooms, and it just works. It's really, really robust. It's even robust in a way that when there are two people aside it, most of the time it stays with one person. That's really, really a thing we didn't expect it to do. And it works with all standard webcams. This means you don't have to buy any expensive accessory. You just use what's normally already in your notebook. And you don't have to use any driver, no driver installation, because you need a webcam driver anyway for your computer, for your system. And if you plug in a webcam, it is normally automatically installed. There is no need for the end user to do anything. So most of the time you don't need any extra hardware, and if you need a webcam, it is cheap. So now how we implemented it. How did we make the communication between our program, our app, and AsTeRICS? This took place with the REST. We made some REST commands, or to be exact, it was developed by the University of Cyprus, and they made this REST interface. Here on the bottom right, top right, you can see part of the manual of the technical specification of this REST interface. It's very nice documented. We made the first version, the first usable version with 2.6, and the actual final version now is in 2.8. So the first line, we just get the model state. So we make a REST call, and this just says, come on, tell us your state. We need this because our application must wait until the AsTeRICS has loaded and is ready. And so first our program waits until AsTeRICS is loaded, and then the state will change to running. The second REST request means that we are starting the model, and it basically tells AsTeRICS, now you should control our mouse cursor. And the next one, the third one, is to pause the model. The reason here is because we don't want the user to use the configuration dialog with the webcam. Normally when you have somebody and he is using and he needs this kind of alternative devices, the configuration dialog is configured by the person who takes care of the client. And so when somebody configures the system, he normally does not want to use these alternative input devices. He wants to use the normal mouse. And so it's very important to stop AsTeRICS so that the camera mouse does not interfere with your normal mouse usage. So these were basically the three commands we used for the communication to AsTeRICS. On this way to the final product, we had to solve some issues because there were some things from the end user's perspective that you just could not keep in the program. Yeah, and so we sat together with the US and told them what kind of trouble we have and where we would need a solution. One thing was when you were starting AsTeRICS parallel to our program, it was blinking in the taskbar because we were basically starting two programs at the same time. And if you're familiar with Windows, you know that sometimes programs just blink because they want to tell you they're ready, all this kind of stuff. The solution they gave us was that AsTeRICS now runs in the system tray. So you have it now here beside the clock, and up there AsTeRICS is starting, and the user is never bothered with some blinking icon at the taskbar. The other thing, what's really a problem is that AsTeRICS does not work if you have, for instance, a Java 34-bit runtime installed in the system. And so for us as a developer, it is very important that we don't change anything on the PC of our customers. It's really hard to make end-user support if the people tell you, my program, the other program does not work after I installed your program. This is this kind of end-user support you don't really want to make, because it means that your program something broke probably something. And so for us it's very important that we deliver the Java with our executable and we don't use anything from the system. Because all the other way is true. If I install my program and I depend on the Java that is installed on the customer's PC, it means if this Java on the customer's PC is wrong, my program will not run. And this is really hard to support and to debug, because how am I supposed to fix a broken Java on a customer's PC? So it's way better and way easier if you deliver the package with an embedded runtime. So no dependencies on the system components, all is in your own package and you deliver everything you need. Another thing was the setup of AsTeRICS installed everything. So this was like it installed all the drivers, all the models we never used, that were never part of our models. And so this needs time and space. And for instance, we had a C++ setup that was also executed. We never didn't use any model with C++. And for a company, for us, the licensing is very, very important. We cannot really face any lawsuit here. So for us, the licensing is important, and we must make sure that we deliver only free software or we deliver only software that we are allowed to deliver. And this means, for instance, if you have the GNU public license, you are, as a company, you're out of luck if you really don't want to show all your source code. So the licensing issue was very important for us, and the starting of AsTeRICS on some developer machines could really take more than 30 seconds. And the solution they provided us was the AsTeRICS building blocks, the APE. And these building blocks really made it good because they only installed what we needed. The licensing files are all together in one directory. You can easily see what's all in there. And now the start is in around 30 to 40 seconds on this developer machine. So that's really, really great. Yeah. And another thing that was quite tricky was the setup for Windows 10, because we first tried to start AsTeRICS with the batch calls, but this worked under Windows 7 and Windows 8, but it did not work anymore on Windows 10. And another thing that was a little bit strange was the virtualization of the write accesses, because when you're a user and you're writing in an area where you are not allowed to write, then Windows will automatically solve this for you and just make a virtualization directory and just write it everything there. The problem here is when I, as an administrator, look in the position, then I see nothing. It looks like nothing happened and nothing has been written, and you must find out in a very tedious way where really the files have been changed. So one of the first temporary solution I made was I made an extra executable, and this one was started as an administrator, and this just started all the other executables. This was a thing that worked for our test cases, but it was nothing I was really proud about, and I was sure I wanted to end and to change this. And the final solution was now that we're installing it in the user directory, and the other virtualization doesn't take place, and all of this kind of extra executable is not necessary anymore. So this is a thing where we had to change the setup quite much because our normal setups don't start two executables at the same time. So takeaways. One nice thing is that models can now be started and paused and stopped with F5, F6, and F7. This was the thing that in our first models we had this extra. This means we had to extra implement this kind of things. Now every user gets this for free. Another thing, what you need is you must test on your target systems. It's one thing that it runs on a developer machine, but if you have any way to test it on 4 or 5 different operating systems with different computers, do it. Even virtual machines might help if you don't have anything else. But there are so many variables you just don't know, and the only way you really can be sure that the stuff works is that when you test. And the third thing is, without maintenance, all software stops working sooner or later. This means you need updates for software because of security, because of stability, because of features. But every update carries a risk. And so this is part of, even in this short development cycle, we had to 2 times to adapt the things that they were going now with new updates. So even if you have something and that works today, you must think about how will you maintain it, how long is the real life cycle for this product, because otherwise you can be sure that after 3, 4, 5 years the thing will not really work anymore, or at least not in the quality you normally deliver. Yeah, so this is my 5 cents of how our development worked and how our implementation worked and how the troubles I was facing implementing this thing. So feel free for questions now. Martin, I think this question is more for you now. I'm not sure. This chat question.
Okay, Boker, I have seen a question regarding the business. Or should we wait for other questions first to answer them from Alfred first, or should I go on?
Well, if there are no other questions for Alfred, then probably we can go on, Martin, and then come back to Alfred.
Okay. Boca, regarding the bitness of AsTeRICS, it's it is possible to use 64-bit as well. That's no problem. It's just for some plugins those require 32-bit, and so in your case, for example, if you it's also even if you have a 64-bit Windows machine and, for example, install the 32-bit Java runtime environment, then it's no problem anyway. And if you use a 64-bit Java runtime environment, then it's only a problem for some plugins. Okay?
Okay. Yeah, I have to dig in more into where my errors or why I'm not getting some of the, actually the demo which I installed, and it has a shortcut on my desktop, and I just, you know, when I double click, it just, nothing happens. So that's, it's not even the model itself.
When you install this demo installer, which one?
It's the, you know, your prosperity for all, BB yes. Demo. So that's one. But I did install the AsTeRICS, you know, the full program, and but when I installed it, your prosperity for all, and it did not. It's not running. It could be maybe, as one of the previous presenter was saying, some administrative, I guess, or some firewall, or some of my IIT, I guess, restriction on some programs to run.
But do you have the 32-bit Java runtime or 64-bit Java runtime installed?
At first, I just run your executable, and apparently you had the Java runtime on it. And then while we were during the presentation, I just installed the 64-bit. But maybe I need to reboot and all that. I will try it test it after the session to see if it helps or not.
Okay, the Java runtime that is embedded in the full AsTeRICS framework, that is only available for the full AsTeRICS framework installation. The demo installer is a separate software application, and it cannot use the embedded runtime of the full framework. And so for the demo installer, that one is dependent on the 32-bit Java runtime. Okay.
Okay.
You could also create a 64-bit version of it, and you could also create a version of it that also has a Java runtime embedded into it. But the installer I provided is based on 32-bit Java. Okay? But I think this is a good example, as Alfred also mentioned, that it can be difficult for a user if you have to force him to install an appropriate dependency like the Java runtime. It can be too complicated, and so that's why we integrated this option that you can embed the Java runtime into your installer executable.
Okay, I'll play around with it more, and maybe I'll email you guys later on.
Okay.
Thanks.
Great. Thank you.
Anybody else? Any questions?
Did anybody else try the demo installer?
Okay. So I guess there are no further questions. So I would like to thank you all, thank the presenters and thank the attendees for being here. This webinar will be available online with captions included in this link that you will all receive with an email, together with the speaker's contacts, and you can contact them in person to find out more about what they presented. The next webinar of the Building Block webinar series will be the RoboBraille converting documents to alternative formats, and it will be realized on 30th of January 2017 at 3:30 p.m. set, and you will be all informed, and we will be very happy to have you there also. So thank you very much for being here, everybody. It was nice having you.
Thank you.
Okay.
Thank you.
Bye.
Bye-bye.